our polar graphs, I split it into 2 days, okay? Today we're going to find areas using just one graph. Next time there's going to be 2, and you're going to find the areas like in between them, okay? But we're going to start out simple. You can read all of this if you want, like if all of this is true, blah, blah, blah. This is your formula. 1/2 integral. You can write a to b if you want, but in polar, we use alpha to beta. So it's just Greek letters instead. You can write a to b. It doesn't matter. From there to there, the starting point to the ending point, r squared d theta. Honestly, it's really easy formula. You stick a 1/2 out front, r squared d theta. The only tricky part is finding the boundaries, really. And then you usually just put it in the calculator. Occasionally you get a non-calculator one. I have one on the back here that will do non-calculator, but that's kind of it, right? So what we're going to do, find the area of one petal of this graph. How many petals is this graph going to have? 3 is odd, so it's going to just be 3. We're going to just draw a quick sketch. I'm going to make myself a little table. It's going to be very brief, though. We're going to keep that part short. We really just want to find our boundaries. And it's going to be 1/2, whatever this is, squared d theta. That's it. That's the formula. It's really easy to set up. The only tricky part is finding the boundaries. And at the end of the day, guess. The unit circle does not have that many options on it. All right, so at the end of the day, pick something. And sometimes they just say set it up, and it's multiple choice, in which case you can narrow down your choices just based on that. All right, so let's see. Let's start with 0 pi. We're going to find our graph. Cosine of 0. 1, good. You can still use your cheat sheet while we're just hanging out in class together. You can use it up until you have a quiz or test, right? Cosine of 0 is 1 times 2 is 2. All right, so 0 pi gives us 2. That's where we're going to start. The next one I would choose to do is pi over 6, because when I plug in pi over 6, it's immediately going to be 3/6, which is 1/2 pi over 2. Cosine of pi over 2 is 0. And it's going to go 2, 0, 2, 0, 2, or negative 2, whatever have you. All right. So the next one I'm going to do is pi over 3, because if I plug in pi over 3, immediately what's going to happen? It'll just be pi. Cosine of pi, good. -1 times 2 is -2. I think that'll honestly be good enough for us to see where our graph is headed. And you only need to go far enough to get the pattern going. All right. So then we go to the pole, or the origin. Pi over 3 would be like right here, but it's a -2. So we went out the other way. So it's going to be down here. And then I'm going to have a third petal up here somewhere. Like I don't need all of it to be perfect. It just needs to kind of be good enough. Can you stop doing that? That's distracting me. So I'm leading the whole expedition. All right. So it's going to go like this. We're going to get our first petal, second petal, third petal, and come back to where we started. Good enough. We just need to get our boundaries, right? Now we want the area of one petal. If we go from 0 pi, which is right here, you're going to kind of have to watch me point to it, to pi over 6. If we go from 0 pi to pi over 6, that's going to give us not a whole petal, but 1/2 of a petal. Okay, so follow me here. If we make our boundaries 0 pi to pi over 6, I'm going to just need to multiply by how many of those I need to get one full petal. So if I want one full petal, I need 2 of that. Do you get what I'm saying there? Like it's a 1/2 of a petal, we just double it, we get a whole petal. Okay. What if we needed all 3 petals? Then I would multiply this by 6. Good job. All right. The 2 and the 1/2 cancel. Slam that in your calculator. Let's just all make sure we can get the same thing. Well, when I drew the graph, we got our point at 0 pi was at 2, and then at pi over 6, it was at 0. So if you go from 0 pi to pi over 6, it's just going to be that 1/2 a petal. I'm not sure how to answer that. I have to kind of point to it to do that. So can you give me a second? I kind of have to point to it. So wait until I get back to the other screen. Did I type that right? I feel like that didn't come out to what I was expecting it to. Two. Oh, okay. I was going to say that was not what I was expecting. There we go.
Yeah.
I knew it was bigger than 1. All right, I got 1.047. What did you get?
I got
Okay.
that.
It's I got that. What did you get? Okay, 1.047. I was going to answer Jack's question real quick, if that's okay, because I kind of need my picture to be able to point to it. So 0 pi is right here. If I go until pi over 6, which is right here, that's giving me just this half of a petal. Like it's from there to there. So I didn't really have a better explanation than it's from here to here. I needed my graph to be able to point to it. Yes, ma'am. Oh, so it says we want 1 whole petal. So this 1/2 whatever r squared d theta, we only went from here to here. That's only going to give us half a petal. So we doubled it to get 1 whole petal. And again, if we wanted all 3 petals, like all of it filled in, you would need 1, 2, 3, 4, 5, 6 times what we did there. Let's try it again. We're going to do a graph. In order to get our graph, we're going to need a little table. And then I would just set it up because you can get like 90% of the formula without doing anything. It's going to be 1/2 integral r squared d theta. You can pretty much set up almost the whole problem, right from the get-go. So how many petals is this one going to have? 5. And again, we're just going to get the ball rolling. We don't need to tediously go through plotting perfect points for all 5 petals. Okay, we just need to do like good enough. So if we start at 0 pi, sine of 0 is 0 times 3 will still be 0. So we start at the pole. I'm going to try and plug in pi over 10. I realize that's not on the unit circle. But if I plug it in, I will immediately get 5/10, which is pi over 2, which is on the unit circle. So this doesn't necessarily need to be on the unit circle, but when you plug it in, the thing you get needs to be. All right, sine of pi over 2 is 1 times 3 is 3. Cool. What do you want to try next? I did pi over 10. Pi over 5, good job. Because that's not on the unit circle, so it's not particularly intuitive. But if you plug that in, you immediately get pi, and sine of pi is 0. I'm going to stop there. I'm not going to do any more points. It's not necessary. You just need to, get it started. Pi over 10 is going to be like here-ish, like somewhere very small in the first quadrant, out to 3. Again, I don't know, like good enough. And then pi over 5 puts us back to 0. So that's 1 petal. And in fact, if you don't even really want to draw the other ones, you don't have to. For the sake of being thorough, you're going to get one that's down here, one that goes straight up, one in the 4th quadrant, and one in the 3rd quadrant. It looks kind of like a starfish or something. If you don't even want to draw all that, you don't have to, because we only need 1 petal. So our boundaries are going to be from where to where? Yeah, 0 to pi over 5. That gives us 1 whole petal. Oh, we don't want 1 whole petal, though. Yeah, sorry, half. Those aren't our boundaries. White out. I just saw that, and I was like, wait, hold on. We don't want a whole petal. We want 1/2 of a petal. So we want to go from 0 to pi over 10. Pi over 10 will give us half of it. I guess the other option is you could go to pi over 5 and then out front put 1/2. You have choices, okay? I would probably do it this way. I know if I go to pi over 10, here, let me fix this. If you want to start typing it in the calculator, you can go ahead. We're just going to all make sure we get the same thing. Reading the question is important.
I got it. Wait. Get that. No, I got that.
Hold up. Wait a minute.
I got this. What did you get? I didn't got that. I'll move the half.
Did you ever do that in your other classes? I got this. What did you get?
Yes.
That's your new thing. Well, that's how working together works. It's not, this is the answer you can copy off of me. It's, I got this. What did you get? 5 theta. Okay, I got 0.7068. Confirmation. When you do your delta math, they don't truncate, they round. I would truncate and put 0.706, but delta math is going to want you to put 0.707. So just, and it's a computer, it's not going to understand, hey, you were really close. It wants you to round correctly. So on delta math, you're going to have to round, not truncate. Yes? I prefer to truncate because it involves less thinking. Like, I'm going to just take the first three numbers, I don't have to worry about it. And on the free response, they'll take either truncated or rounded, but delta math wants rounded. So, but yeah, I guess personal preference, but don't you want to do it the easier way? It's around, then you do you. All right, but I have to tell you, if you put 0.708, they like nothing. They will give you no credit. It has to be perfect. Let's try another one of these. No, I was just being quiet while I wrote stuff down or did you need narration for that? I made a grid, I made a little table for theta and r, and then I set it up. 1/2 integral r squared d theta. We just need to find our boundaries. Now we want the inner loop of this. Yeah, it's going to be like a heart thing with like a, well, technically the cardioid is the one that has like the cusp. You know what I'm talking about? It looks, but anyway, it's called a limacon or a limacon. I think it's son, like limacon, because the S has like the little, anyway. Let's see what we get. We're going to start with 0. Cosine of 0, 1 times 2 is 2. So 1 minus 2 is -1. So that's actually going to be over here. So over yonder, the opposite direction. All right, I'm going to try pi over 3. Cosine of pi over 3 is 1/2. That's why I picked that. It turns out nice. All right, so cosine of pi over 3 is 1/2. Times 2 is 1, and then 1 minus 1 is 0. So far we've got this. I'm going to keep going so you can get the whole picture for this one. Next, I'm going to do pi over 2. So we're at the top of our unit circle. Cosine of pi over 2, 0, 1 minus 0 is 1. So now we're up here. And we only need to go a little bit further. Let's do pi next. Cosine of pi would be -1. So the negatives are going to cancel, and you're going to get 1 plus 2, which is 3. So now we're all the way over here. Yeah, well, it's going to connect back. Just didn't get there yet. Well, it's going to, here, do you want me to just finish it? It's going to go like this. And my picture is not great, but like it's going to do that. Good enough. We got far enough that we can get our boundaries. Like we can see what it's going to look like. Yeah, this will be -1 right there. Yeah, for symmetry's sake. All right, so what we want is this inner loop. So let's see, 0 pi put us right here. And I kind of don't have a better explanation than, hey, look. So look at the point we're at. Pi over 3 took us to 0. So if we go from 0 pi to pi over 3, we get just half of it. Do you see that? Like half of the little inner loop. So what I would do is I would go from 0 pi to pi over 3. And because that's only half of what we want, multiply it by 2. And it's actually really convenient to multiply by 2 because then, yeah, those are gone. And then we're going to just put it in the calculator. So everybody just try and type it. Make sure we get the same thing. You know, I actually don't know the answer to that. I can Google it if you want and get back to you. That just is the formula for how you get the area. No, I mean, I probably should know the answer to that. I'll be honest, I don't know the answer to that. I've always just been like, okay, this is the formula. That's how we use it. And I never kind of questioned it. Oh, gosh, you're fast. I didn't even type it yet. Hold on a second. 0.5 something? I'm listening to you. Go ahead.
Oh, yeah.
No, I accidentally cut it and made a pie.
Oh, wait, that's interesting. Wait,
I don't know why.
Wait, that's
0.544? Okay.
curious why this is.
You make the data into three makes it pop.
Yeah.
How do we use
It's a phenomenon.
and math? So weird how like this randomly shows.
Yeah.
I don't know who decided, but for AP, because AP has to be standardized for all the people doing it, they were like, we're doing radians. So, but here, let's, oh my gosh, can't type.
Word.
Let's see. I'm curious now. It's thinking, the AI. Come on.
Who comes up with this?
Oh, circular sectors. So it's 1/2 pi r. So pi r squared is that what that means? Pi r squared is a circle.
Yeah, that's what it is. Not the radius, zero, but it's kind of
Yeah, but why?
That's a question.
I don't know. It's a good question.
Oh.
I don't know the answer.
Coronavirus disease.
So then if you bring like a backpack with your glove and
Oh.
and that.
Yeah, so area is pi r squared. Oh, I see. It's so because the whole way around the unit circle is how many pi? 2 pi. But the area of a circle is just 1 pi r squared. So we put a half in there to get rid of the 2. There, we all learned something. So again, the whole way around is 2 pi, but the area of a circle is just 1 pi r squared. So we put a half. Oh, cool. Now I learned something too. Thank you. All right, are we good to flip over? Okay. All right. This is the one we're going to do non-calculator, and you'll see why. It's going to work out. All right. So we're going to find the area of this thing. It's going to be 1/2. It's going to be r squared, but hold on a second. D theta. This is your r right here. If we do this squared, what is going to happen? Yeah, the squared and the square root cancel out. In fact, I'm even going to put the 6 out there, if that's okay. I'm going to evict the 6. And so all we have in there is sine 3 theta d theta. So we'll be able to do this one non-calculator. Okay. You can move a coefficient. You can't move a variable. So you can't ever take a theta out of an integral. You can't ever take an x out of an integral. But if it's just a coefficient, sometimes it depends on how the problem looks. In this case, I would like to get rid of it. It's a coefficient. Well, a constant is something that's added on at the end. A coefficient is multiplied. All right, so to get our boundaries, we want to go from where this touches the pole around to 0. If you square 0, that will still be 0. And if you divide 0 by 6, that will still be 0. Okay, so it's just going to be sine of 3 theta equals 0. I don't want to write out all those other steps. It's all just going to be 0. So where is the first place that sine is going to be 0? 0. And then if you divide by 3, 0. So what's great about the unit circle? You get a lot of 1s and 0s. Now, where is the next place sine is going to be 0? Pi. On the left side of the unit circle. So y value, yep, exactly. And then, so if you divide by 3, you get pi over 3. So those are our boundaries. Antiderivative of sine. You need to come up with a function that if you did the derivative, you would get sine. Perfect. Negative cosine of 3 theta. There was a u substitution in there, but we're not going to write out u equals this and the whole blah, blah, blah. If there's a 3 in there, out front, you simply put a 1/3. Now, what's really nice about this, though, is what's in front of this? Half of 6 is 3, and so those are going to just divide out anyway. And then this is such that it is a negative 1/3. Your antiderivative of sine is negative cosine. I should put it in parentheses. Give it another hug. So the 3 and the 1/3 divide out. It's really just negative cosine, right? I'm going to have to come down here. I ran out of space. Upper minus lower. So let's do pi over 3. If you plug that in, you immediately just get 1 pi. So on the left side of the unit circle, what is cosine of pi? Cosine of pi is -1, but there's a negative, so +1. You should never get a negative area. I told you were allowed to have your computer out as long as Desmos was the only screen and you still paid attention to me. We're not using the calculator for this one. All right, if you plug in the lower boundary, 0. Cosine of 0 is 1, but there is a negative, so -1. And this totally geeks me out. The answer to the entire question is 2. The area of this is 2. I love that. That like makes me so happy. I don't know why. That just like satisfies my brain. Like that's just 2. Did I ever talk about this with you? Do you know that whenever you have your sine and cosine graphs, which one is this, sine or cosine?
Sine.
That's sine. Do you know that the area of each bump is also 2? So type it in, integral 0 to pi of just sine. And then, so just half of it is just 1. Like each of these is 1. Anyway, that totally geeks me out as well. Integral 0 to, do you see that? It's just 2. Isn't that neat? Neat. All right, 2 more. Write an integral. So we don't have to actually work it out. We're just going to write an integral that gives the total area enclosed by r. And this is sine squared, so just heads up. As shown in the figure to the right. So 1/2 integral. I think it looks like a snowman, but only like 2 bumps. Or an infinity symbol is really. It's called a lemniscate.
Oh, I was talking about the one below it.
Oh, the one below it? Oh, that looks like a what?
Gingerbread man whose like head was split.
Oh, geez. Okay. Well, we're not on that one yet, so just hold on. All right, so getting your boundaries. We're going to go from here around until we get to there again. So we're going to get the area of just like the top loop. All right. We just talked about it up here. Sine is 0 at 0. And then the next time it comes around to 0 is pi. And then if I want the area of the whole thing, I'm going to multiply by 2, which again is convenient because these go away. You don't even need to type that in the calculator because all it said to do was set it up. Now, if you are finding that in multiple choice, instead of sine squared, they're going to write sine to the 4th. Okay, just to make sure you can choose the correct answer. Yes, go ahead. Yes, so sine is 0 at 0, and then we go around, and when we get back to 0, the next place on the unit circle that happens is pi. Correct. Yep. The other option is instead of 0 to pi, you could go 0 to 2 pi and then keep the 1/2 out front. So you have options. All right. So for this one, again, go ahead and set it up. Oh, you know what? Do you see how this is r? Does anyone want to copy all of that again? No, I'm going to just write r squared if that's okay with everybody. Just when you type it in the calculator, be really, really careful. Also, I'm not really going to even think about plugging anything into this. If I start here, that's 0, right? 0 pi. If we go the whole way around, 2 pi. It wasn't any more complicated. It's not like we had 2 sections of the graph. We started here. We want to go the whole way around. That's 2 pi. I want everybody to practice typing this because this one's a monster to type. And, you know, sometimes you got to be able to get through the button pushing. 2 pi.
2 pi, sorry.
Because we go the whole way around.
Does it matter if you type 0 pi or just 0?
Oh, no, just 0. I like to put pi on there, though, because otherwise people tend to confuse it with, like, the 1s and 0s that are on the unit circle. Yes.
Also, what if we just put like that 1 by 2, but down from 0 to pi?
I don't think the symmetry, no, because that,
Lack of symmetry in pi?
well, the graph has some kind of symmetry, but it's like in triples instead of, yeah, I just wouldn't go there. Technically, you could find a way to make it work, but I don't think that's worth it. Oh, geez, you're fast. Hold on a second.
I got 5 for this.
Really?
Oh, that is.
I don't know.
Oh, I didn't know.
I was high school.
3.63. Divided around.
You got it.
I was really excited for a second.
I got 3.632. Is that
Yeah.
okay? So that is B. Now I went through these and checked at one point. I think one of the correct answers is if you leave off the 1/2. Let me see here because I want to show you how evil they are. If I get rid of the 1/2, is that one of the answers? Yeah, that one's D. Now if you keep the 1/2, but I think you get rid of the squared. Like if you forget the squared, or did somebody mess up and forget the squared? What answer is that? Yeah, that's A. And then I think C. I can't remember. C might be if you remember the squared, but your boundaries are wrong. Like if you try, let me see if I'm right. Is that what C is? No, you know what? I don't remember what C is, but they're all very close to the right answer. Like if you just mess up one tiny little thing, it's gonna not give it to you. They're not very, that's what I'm trying to tell you. It's you and me against the AP exam, and I'm trying to prepare you for that. Okay. That went really good. I understand if, hold on, let me hit stop before I keep talking.